I'm going to run through parallelograms real quick. We are taking a few things and reducing them for these Webex things. You're going to see the online notes from last semester and my previous YouTube videos cover a couple of the tidbits. I encourage you to go look at those things. We're going to keep just to the very basics and just focus on parallelograms, which is right here. So let's make sure my pen works. Okay, right here is my parallelograms. Okay. So eventually we'd like to explore the entire quadrilateral tree. There's a lot of fascinating things involving quadrilaterals, and it applies to future classes if you take those kind of classes and elect to do so. So again, we're going to just focus on parallelograms. A parallelogram is a quadrilateral with all the properties of a quadrilateral, which is basically the angles, interior angles up to 360s, and it has 4 sides. Has all the properties of a trapezoid, but we haven't talked about those. A trapezoid is a a quadrilateral with at least one set of parallel sides. A parallelogram is a quadrilateral with both sides, both opposite sides being parallel. So let's move on. So we want to talk about what is a parallelogram, how do we prove it, how do we dissect it basically. Again, a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So here's a side here and a side here. They're parallel, and opposite sides are parallel. You may remember this from a previous course in middle school. Because their opposite sides are parallel, our opposite sides are going to be congruent. Now, there'll be different lengths sometimes they're not. That'd make it a rhombus. But this could be like 10, and this can be like 8. Okay? If that's 8, this is going to be 8. If that's 10, that's going to be 10. Because of what we studied previously, given parallel lines, same side interior angles are supplementary. So if this is 80 degrees, this will be 100. So these are also called consecutive angles. So same side interior or consecutive angles are supplementary. That makes opposite angles equal. So that's an interesting little tidbit, because if these are supplementary, these have to be supplementary, and that makes opposite angles equal. Moving on. Again, as always, you should be pausing, absorbing, and then hit and play again. So whenever we have polygons with more than 3 sides that have diagonals, and here's 2 sets of diagonals. Now if we have a parallelogram, this adds in a whole lot of new stuff. Because one of the things you learned about in given parallel lines and alternate interior angles, this right here and this right here, alternate interior angles, they're going to be congruent. And in addition, these are alternate interior angles. Oops, right here. So angle, if this is going to be 50, this is also going to be 50 degrees. Okay? So given parallel lines, alternate interior angles are congruent. So remember that one. The other tidbit is that diagonals will bisect each other. So if this diagonal is these 2 diagonals, when they cross, they create bisecting. So if this is 6 inches, that's going to be 6 inches. And if this is going to be, these are going to be equal as well. So if that's 8 and that's 8. It doesn't mean that they're going to be equal. If you see something that's leaning, these diagonals will not be equal. Take a look at this. This one's going to be a lot longer than this one, even though I'd marked them the other way around. Okay? So this will be longer than that one. So that should actually have been 8 and those have been 6. Moving on. So we want to learn how to identify, name, and so on. When we name these, they're named off their vertices, which are capital letter M and P and Q for this one. And we need to do this in a consecutive manner. It doesn't matter where we start and how we name it. We could do MQPN, PQMN, but we don't want to do something like this, MPQN, because we have to go along the sides and not the diagonals. So when I say MNPQ, I know I have a parallelogram. I could start anywhere on here. M, consecutive, N, P, and Q. Alright, opposite sides are parallel. We talked about that. Opposite angles are congruent. Consecutive angles are supplemental, and diagonals are bisected. These are your 4 main properties you're going to deal with, and we're going to throw problems at you. Again, there's 2 ways to do geometry: proofs and by algebra. We're going the algebra method. That means we're going to give you problems where you're going to have an algebra problem, and you're going to use your properties to solve for x, solve for a side, or something like that. So here we have a parallelogram. One of the things I would recommend is go ahead and mark your parallelogram. Opposite sides, these are little arrows, are parallel. Okay? Next thing we want to do is name it. We want to label it A, B, C, D. It doesn't matter where you start A, and I tend to go just around the parallelogram, so I'll put A here, B, C, and D. Then I'm going to say, what did they give me? They gave me x. So I'm going to put an x right here. And they gave me D as 2x minus 3. So I go to those 4 properties, and I kind of run through them on my head. Well, we're dealing with angles. So there's only 2 properties we need to deal with angles. Opposites are equal, and consecutives are supplementary. That means this plus this is equal to 180. That's exactly what I'm going to do. I'm going to do x plus 2x minus 3 is equal to 180. That's 3x minus 3 is equal to 180. Add 3. And that's going to go into 60 plus 1 times, so 61 times. That's 61 degrees. 61. Okay? So this is equal to 61 degrees. This is its supplement. Opposite's going to be 61 degrees. 180 minus 61 is going to be 119 degrees. Okay? So D is equal to 119 degrees. I would work this one out separately and then check your answers again. So example 2. So we got x, y, z, w is a parallelogram. So I'm going to go ahead and label. I usually just tend to start right here and work my way around. X, y, z, and w. Then I'm going to fill in what I know. Diagonals. Alrighty, let's draw some diagonals. XZ. Now I always have a hard time drawing straight with this writing device. Close enough for government work. And then YW. There we go. So intersect at point A. So I'm going to put a little A right here. And what else are we given? XA is 3m. Ha! You almost think that's 3 meters, but that's like x. You can always put 3x if you want to, but I'll use 3m. Whoever wrote this needs to, well, let's see. And ZA is 5m minus 4. All right. The other definitions, diagonals, bisect each other. So this is equal to that. So I have 5m minus 4 is equal to 3m. And we're going to solve that. We're going to subtract by 3m. So I'm going to have 2m minus 4 is equal to 0. Add 4. Divide by 2. And I have m is equal to 2. So I put a 2 right here. 3 times 2 is 6. And hopefully I get a 6 over here. 5 times 2 is 10, minus 4 is also 6. So my lengths are 6. Moving on. So here I have, we need to prove that it needs to be parallelogram by determining what x and y must equal to for it to be parallelogram. Well, we go through and run our definitions again. Consecutive angles have to be supplemental, and opposite angles have to be equal. I don't want to do 4x minus 20 is equal to 8y. That gives me a system of equation. We can do it, but let's just skip that by taking care of my consecutive angles. These have to add up to 180. So I'm going to have 8y plus 10y. That gives me 18y's is equal to 180. Gotta love this one, because when we divide by 18, we just get y is equal to 10. So we're going to plug that in. I would plug it into this one. This is going to be 80. This is going to be 180. All right. 100. They add up to 180. This is going to be 80. And this is going to be 100. I just simply put 4x minus 20 is equal to 80. 4x minus 20 is equal to 80. Add 20. And then I divide by 25. Divide by 4, I get 25. All right? So y must be 10, x must be 25, for this to be a parallelogram. Okay, what variables must be x and y for this to be a parallelogram? That means we need to have opposite sides equal. So we could do 2y minus 3 is equal to 2x plus 1, but that goes yuck. We got a system of equation. Can still do it. We just need a second equation. We just might as well take care of this first. Let's put this side equal to that side. So we're going to do 4x minus 9 is equal to 3x plus 3. Subtract 3x. I get x minus 9 is equal to 3. Add 9. X is equal to 12. All right? So x must be 12. Now, if I were to plug x in, that's going to be 2 times 12 plus 1. 24 plus 1 is equal to 25. So this side's 25, and this side has to be 25. So I'm going to take this y right here and equal it to 25. 2y minus 3 is equal to 25. Add 3 and divide by 2. All right? So these are the values that x and y must be in order for this to be a parallelogram. Any other values, it is not a parallelogram. Alrighty. So I think this is our last one. Maybe it is. So for each value of parallelogram for x, y, and z. This is just a simple exercise that we're going to run through because it reinforces our angle definitions. First one is opposite angles are equal. So this has to be 80. Our next one is consecutive angles must be supplemental. 180 minus 80 is 100, so this has to be 100. So z is 100. The next one is given parallel lines, alternate interior angles are equal, so y must equal to 80. That's it. All right? Now, real life vectors. One time I flew into the Azores, and that was a pretty exciting mission because I thought I was going to die. Because the crosswinds were like 50 knots. So what happens is when you're approaching the runway and you want to end right here, you're going to have to turn your aircraft into the wind. So if you want to get to there, but the wind is blowing this way, what's going to happen is if you were flying this direction and the wind was blowing you, you're actually going to end up over here, okay, into a mountain. So what you want to do is you want to turn the aircraft into the wind, and the wind and your thrust will carry you right along the diagonal to your destination. So that keeps you from crashing into mountains. That's a good thing because plains and mountains do not mix. So when planes are flying, they're actually flying the diagonal of the parallelogram of their thrust and their wind. This is actually vectors, and vectors is something that you study in pre-cal, actually combined with a lot of trigonometry. Okay, so I'm going to go ahead and get going and get this loaded, and we'll see you on Webex this afternoon or tomorrow or one of those days. Okay.